Hello everyone. My topic is on rainbows. So the major parts and functions of this is the beam of sunlight coming in and the raindrop itself. There's millions of these in the sky, so that's what forms the bow. And the physics behind this is that the white sunlight enters the water and then it refracts, and since the red light and the violet light and all the different colors have different wavelengths, they slightly separate. And then they hit the end of the raindrop and they reflect. And then when they hit the water on the other side, they refract again. So this increases their distance from each other slightly more. Typically the violet has around a 40 degrees between the original sunlight ray and when it refracts, and the red has about 42 degrees. It's slightly more dramatic on this diagram, but that's just for visual purposes. Important formulas to help you with this is the formula for refraction, which is n1 sine theta equals n2 sine theta, and the formula for reflection, which is the incandescent angle equals the reflected angle, which is seen right here. So conditions to form a rainbow is that you must be having your back face towards the sun so that the ray of light can refract twice and reflect and come into your eyes. And there must also be some distance between you and the rain droplets, so you can't have a rainbow like very close to you unless it's like in your sprinkler. And the way that rainbows appear as giant bows instead of giant mass of little rainbow dots is because of the way that the light sort of separates when it leaves the raindrop. Each little raindrop refracts and shows off the entire spectrum, but since they're very far away, you can only see certain parts coming off from each dot, as seen here, as each of these dots gives off the whole spectrum, but your eye is at the right angle so that it only sees the red beams from the top and the orange, yellow, green, blue, all from so on and so forth, and the violet rays, which project at the highest, are seen as the bottom, which is kind of emphasized more down here as it's half these light beams, and then that's what the rainbow would look like. Let's see, rainbows improve life because they are an important tool to help people understand prisms and the spectrum. It's a basic introduction to how the physics of prisms work. It can help kids and everyone who's seen a rainbow help people become interested in science and physics and all of that. And some fun facts is that rainbows are actually full circles, as seen here. Most observers cannot see it because the full circle is blocked by the horizon. Mountain climbers high up and airplane pilots may be able to catch the entire circle in the correct conditions. And also, you cannot reach the end of a rainbow because as you approach it, you become too close to the original rainbow to view it. So the new rainbow, as you're seeing, is actually just the same one as before, kind of, but it's pushed slightly back because as you get closer to here, there's more raindrops sort of back this way, so it's the same idea, but the rainbow pushes back as you go forward, so you're never actually going to get to the gold at the end. So you can always go after rainbows, but you ain't get nothing. So I guess that's my presentation. Yeah.